So if you want to learn quantum computing, you have to learn linear algebra because quantum computing is based on quantum mechanics, and quantum mechanics is very heavily interwoven with linear algebra. And linear algebra, it's just the study of vectors, vector spaces, linear operators. So a vector you can think of as just being, an arrow pointing in some direction, right? In some space. Here, this pin is an arrow that is pointing in 3D space. And by 3D, I mean I have one dimension going left, right, one dimension going up, down, and one dimension going back, forth, right? So I can usually think of a vector, if this is my X, Y, Z, three coordinate system that I might have learned at some point. If I have some random arrow out here, right, that's a little too close to that. I don't like that very much. Let's draw my vector out here. And it lives in 3 space, so, it casts a shadow, something like that, right? So it's kind of pointing out a little bit. So this is a vector, and what quantum computing is, we're going to set up a vector in space, kind of like this, but in a multi-dimensional space, and we're gonna rotate it around through some manipulation of quantum information. We're gonna rotate it around, and eventually we're gonna stop it, and we're gonna see what direction is that arrow pointing. And so we're gonna use the tools of linear algebra. And when we say vector, you can just think, for all intents and purposes, of just, a list of numbers. So let's say I have a vector v, and v equals, the numbers 1, 2, 3. And let's say I have the vector w, and the vector w equals, 5, 0, 5. Right. And so I just have these two. I have one arrow in space v that looks like this, and one arrow w that, let's say it looks like that. Whatever. And I can add these two vectors together. So I can define an operation called addition, which is v plus w, and that's going to be these two entries added together, these two entries added, these two entries added together. So that's going to be 1 plus 5. The next entry is going to be 2 plus 0. The next entry will be 3 plus 5. And so, that gives me, let's say, 6, 2, and 8. I'm not going to spend too much time on the addition of vectors, but that is one of their very fundamental properties that they have. They can also be multiplied by a scalar. So if I say, 2 times the vector v, well, that's just the number 2 multiplied by each of these numbers. So 2 times v, that's going to be 2 times 1, 2 times 1, 2 times 2, and 2 times 3. So we get the values 2, 4, and 6. And so in some sense, we've taken this v and we've doubled, right? We've doubled the length of it. We've scaled it. That's why we call this to a scalar that we're multiplying it by. And that's just the quick introduction to linear algebra that we will need, and we're gonna do a lot more linear algebra. We have to have a solid foundation in the mathematics of vectors. The only other thing to mention about quantum mechanics specifically, quantum computing specifically, instead of using this V with an arrow across the top, we're going to use a notation called a ket. Ket. So K-E-T, a ket. And this ket looks like, a bar, and then my label, and then some little arrow looking thing, right? So this is the vector V, but it's in this ket notation. And in general, this is called, bra-ket notation, and it's due to a man named Paul Dirac. And so we will get to this later, but a bra, let's say the vector W, I draw it kind of in a backwards arrow. Instead of a right-facing arrow, it's a left-facing arrow. It's going to be this vector, but turned sideways. 5, 0, 5. And we need to do that just to make the mathematics work out when we start multiplying these things together. So that's the notation, that's the idea. Just a quick refresher on what a vector is. You can define a vector as an ordered set of numbers. You can add vectors together as long as they have the same dimension. So this had 1, 2, 3 components. This had 1, 2, 3 components, so we can add these together. And you can also scale vectors up, and we will use this bracket notation for vectors. We'll see plenty of this, don't worry.